Customers demand quality, but how do you define it? It's the ability of a product to consistently meet or exceed customer expectations. In short, complete customer satisfaction. When must quality issues be addressed? It begins with the design of a product or service and is affected by every step in the process of producing the product or providing the service. In progressive companies, quality involves everyone in the organization that produces the product or service. New computer-based technologies are helping businesses to not only ensure consistent quality, but also to achieve continuous improvement in their processes. Techniques such as quality function deployment utilize focus group studies and other methods to integrate the voice of the customer into the product development process. Desired features and requirements are identified and their importance is weighted. This becomes a guide to management and the design engineers. CAD/CAM systems integrate computer-aided design with computer-aided manufacturing software. Designs are evaluated before physical prototypes are made. Simultaneously, the design teams must look at the manufacturability of the product design. Efforts are made to reduce the complexity of components to simplify the job of building a quality product cost-effectively. To ensure predictable reliability, the Detroit Diesel team performed rigorous field testing of the Series 60 engine before its introduction. Over 22 million miles were logged during engine tests, including a grueling 24-hour-a-day test track operation that went far beyond normal expected customer use conditions. The Series 60 team also found that designing quality into the process and getting everyone involved with the quality process reduces the need for inspection. And this is a key reason why the assembly workers are a critical part of the quality assurance function. In-process inspection is preferred to post-process inspection because it allows corrections to be made to the process sooner, to minimize the production of unacceptable products, and it prevents adding value to the products that will be rejected due to defects.
When we realized the reliance on inspection was not the way to achieve world-class quality, it became apparent that employees had to be able to check or inspect their own work and the work of the employees prior to them in the process.
The automatic guided vehicle that carries the engine does not travel to the next operation until the problem is identified and fixed. The Coordinate Measuring Machine, or CMM, is one such tool. On a CMM, a probe is moved into 3 axes by computer-controlled servo drives. By touching several points on surfaces or features of a product component, the probe measures the component to verify dimensional accuracy. The CMM itself is highly accurate and repeatable. Error is typically a fraction of 1/1000th of an inch. At Detroit Diesel, a CMM is used to check the first machined part of a batch before more are made. A sampling of each batch is also inspected to detect any drifting of tolerances or other detrimental trends that could affect quality. CMMs are also used during product design and development to analyze prototypes and refine tolerances and specifications to ensure a reliable quality product that functions optimally. This also speeds up the development process and lowers development costs. Another computer-based quality tool is SPC, or Statistical Process Control. SPC is used by many manufacturers to compare inspection measurements to a standard, then evaluate the data to spot any detrimental trends and correct the process if necessary. At Detroit Diesel, for example, SPC is used to control parameters on operations, such as the torquing of bolts during engine assembly. As with all SPC, a predetermined range of variation is allowed to compensate for slight variations in tool performance. Beyond that range, there is reason for concern. SPC control charts allow management to distinguish between random variations and non-random variations, and to detect if the process is drifting away from the standards that have been established for optimum quality. Designing the product and the process for success. It's accomplished by using advanced techniques and tools to ensure quality. An optimized product design, based on both customer requirements and on manufacturability, is followed by implementation of a process that assures consistent quality with the highest efficiency.